Okay guys, in section 9.3 we move from sketching parabolas to sketching an ellipse. Remember, an ellipse is basically an oval. By definition, it's the collection of all points in the plane, the sum of whose distances from two fixed points, called the foci. So we have two focuses, two foci, right here and right here, is a constant. So the sum of the distance from these 2 points, so anywhere I move along the edge of the ellipse, the sum of these two distances, the distance from focus 1 and the distance from focus 2, is going to be a constant no matter which point I'm at, because as I move closer to one focus, I'm moving further from the other. I also have two vertices, vertex 1 and vertex 2. So we have two axes. We have a major axis and a minor axis. Notice that the major axis is the axis that goes through the length of the ellipse. The minor axis has the shorter distance. The major axis contains both vertices and both foci. Now, an ellipse is formed by using those two foci, and I'm going to do a little demonstration here. Hopefully this is going to work well. So here are my two foci with my string attached. This string is the same length no matter where it falls, right? So if I pull it up here, or if I pull it here, or over here, this length of the string does not change. So I'm going to use that string to draw my ellipse. Now I have to get my hand in the way because I need to hold my foci in place. So I'm just going to take my string and I'm going to stretch it out so that I can sketch my ellipse, my set of points that are, oopsie, I pulled my string out of my pen out of my focus. I'm going to have to turn it around because I can't do both sides very well. But you can see that I'm using one string, and the length of that string, the sum of the length of the string is going to be the sum of the distance of the points from the two foci. That's how I form my ellipse. Alright, so the string is a constant distance. If I pull it here, this distance from the point to this focus and plus the distance from this point to this focus is the length of my string. If I pull it here, those two distances are still, the sum is equal to the length of the string. Pull it over here, it's the same. So the ellipse is made up of the set of points that are the sum of the distances from both foci. Awesome, that worked better than I hoped. Okay, let's analyze an ellipse. We are not, it encourages us to use the distance formula to find the equation for the ellipse. We're actually going to skip that. We're not going to do that. It gets unnecessarily complex, and I think that you guys can comfortably see the equation on the next page, and we're going to be okay. Now notice that the way I have this ellipse drawn, the major axis is the x-axis, and I know that because it's the longer side of the ellipse, and it contains both foci, and we label those edges the vertices. The center of the ellipse here is at the origin. Now we're going to start analyzing ellipses that are centered at the origin, and then we're going to move away from that. So again, we have two foci, we have two vertices. These would be the two vertices, vertex 1 and vertex 2, on the major axis. And then we have this distance from the center to the edge of the minor axis, and we're going to learn how to measure that, but we aren't going to call these vertices. The distance from the center to a vertex will be A, and the sum of the distances from the foci to a vertex is 2A. That is going to be less important than finding and labeling our A, B, and C. Okay, let's look at the equation of ellipse with a center at the origin and the major axis along the x-axis. So here's what that equation is going to look like. That equation is going to be x squared over a squared plus y squared over b squared equals 1, where a is greater than b They're both positive. And then I have this little equation here. Now there's a couple of things to remember that are very important. First of all, this a square is always going to be greater than, a is always going to be greater than b. So wherever a square is, that tells us where the major axis is. Because the a square is always the larger of these two values, and it always signifies the major axis. So it is always below the major axis. So we're going to jump ahead just for a second and look at the next page. If we have the equation of an ellipse whose major axis is the y-axis, it's still x squared plus y squared in the numerator, but since the major axis is the y-axis, the a squared will go below it. So the a square, the a is the larger value, so the a square is always larger than b square, and it will always go below the major axis. That's how you know which axis is the major axis. Something else that you need to recognize, you see that we have a little right triangle here, but C is not the hypotenuse. The hypotenuse is A. So remember that on an ellipse, that triangle ABC that is formed here is a right triangle, but C is not the hypotenuse. Instead, my longest side, A, is the hypotenuse. A is also, so this distance is A. A is also this distance. The distance from the center to the vertex is the same as this distance. Now, these values for A are the same even though the sketch is not drawn to scale, okay? Sketch is not drawn to scale. So A is the distance from the center to a vertex. A is also the hypotenuse of this little right triangle here. Notice that C is the distance from the center to a focus, and B is the distance from the center to the edge of the minor axis. B also shows up here. So this is how we find B. This is how we find A if we're given the equation. And then we can solve for C. Or if we're given C and A, we can solve for B. This is what we're going to use to solve. Remember that A is my hypotenuse, B and C are the legs of that right triangle. Okay, let's put it into practice. I'm going to find the equation of an ellipse based on the information that we're given. Well, we're told some things. We're told that we have a focus at -3, 0, and we have a vertex at 5, 0. So let's plot those points and see what we can do with that. If we have a focus at -3, 0, that is our focus, and we have a vertex at 5, 0, that is a vertex. Well, what else can we do with that? I see that I've got the focus and the vertex on the x-axis. So I know immediately that my major axis is my x-axis because it contains both the focus and the vertex. I can also find the other two foci, the other focus and the other vertex, right? Because if I have a focus here, well, we're told, we're told the center is at the origin. So we've got a center at the origin. There's C. So if I have one focus here, we're going to call this F1, 3 units from the center to the left, I will have another focus here, 3 units of center from the right. And that distance from the center to the focus is C. So C represents the distance from the center to a focus. And for this equation, C is 3. I have a vertex over here. We're going to call this vertex 2. It's 5 units to the right, so I can go 5 units back to the left to get my other vertex. That distance is A. Distance from the center to a vertex. And for this ellipse, it is 5. Now I need to find B. I'm operating on this equation that we've been given because my major axis is the x-axis. So I know that I have x squared over a squared because a is the larger, it's under the major axis, plus y squared over b squared equals 1. And I'm going to find the values for, I've already got a, I need to find b. Now I'm going to find b, that distance from the center to the edge of the minor axis. I'm going to find b by using b squared equals a squared minus c squared. So b squared equals a squared minus c squared allows me to find b. B is the distance to the edge of the minor axis. So for this case, I've got 25 minus 9. Square root 16 is 4. So to get B, the distance to the edge of them on the minor axis, I go up and down 4 from center. Now I'm a really cruddy drawer of ellipses and circles and things, so you're gonna have to imagine that this is extremely elliptical. Oh, it doesn't look too bad. That went out to, should not have gone past 5, but you can see that I did my best there. Okay, the equation of the ellipse. Well, we have x squared over a squared, where a is 5, so that's 25, plus y squared over b squared, where b is 4, is equal to 1. That's the equation of my ellipse. And we've already finished our graph. So let's move on and do another one. This gave us points, and we found the equation. For the next one, we are given the equation, and we're told to find to build the graph. Okay, so our equation is x squared over 16 plus y squared over 8 equals 1. Well, first of all, what's my major axis? My major axis is going to be the x-axis because this value is larger. So that tells me that a is 4, and this is going to be b squared, so b is the square root of 8, which is 2 square roots of 2. So my vertices are going to be 4 out from center. Where's center? Well, just like with all of the equations we've been doing up to this point, if center is moved away from the origin, I have x minus h and x minus k. In fact, let's look at, just glance at this table a couple of pages in our notes. You can see when I move center, I've got x minus h and y minus k. I think I said x minus k a while ago. It's x minus h and y minus k, no matter where I move it to. And again, a square goes underneath the major axis, whichever axis that is. Well, I can see from this equation that I haven't moved center away from the origin. So my center is going to be at 0, 0 at the origin. So I can start graphing some things. We know my major axis is the x-axis. My vertices are going to be 4 units away from center. So I can move out 4 units to get my vertices. So my vertices are going to be at negative 4, 0 and positive 4, 0. The next thing I can do is to find the distance to my minor axes is already here. I already know that, right? So because b is square root 2, 2 square roots of 2. This is the distance to the edge on the minor axis. Distance to the edge on the minor axis. So 2 square root 2 is not quite 3. So I'm going to go up there and I'm going to go down there. So those are the edges on my minor axis. So I can see where my ellipse falls. I still need to find the foci. Well, to find the foci, I'm going to use that. Remember, my equation I was given was b squared equals a squared minus c squared. Well, the foci are going to be c distance from the center. So I need to figure out what c is. That means I'm going to solve, I move my terms around and rearrange. I would have c squared equals a squared minus b squared. Remember, for all of this, a is my hypotenuse, so it's the longest side. C squared equals a squared minus b squared. This is a squared, this is b squared. So 16 minus 8 square root is square root 8. So the foci are going to be 2 square root 2 out from center. So that's almost 3. So foci are going to go here, F1, F2. So my foci are at negative 2 square root 2, 0, and positive 2 square root 2, 0. There are my foci, there are my vertices, and here is my center. If I sketch this ellipse, try not to go past anything I'm not supposed to go past this time. That looks a little better. Still a little squiggly, but a little better. How did we figure out which axis was the major axis? Well, the larger value, always a square, is below the major axis. So when I'm looking at my equation, that's how I know which one is the major axis. Okay, we already filled this in, so if we have our y-axis is our major axis, then a square is underneath y square. Our sketch looks the same, it's just been rotated so that the length, the long distance of our ellipse is along the y-axis. Let's go ahead and look at our next example where we work with an ellipse that is centered on or paralleled along the y-axis. Okay, this starts us in a little different place. We're going to analyze this equation and graph our ellipse. Now, this is not in standard form. It's not in that graphing form that allows me to find my values, so I need to get it there. Standard form is always equal to 1. Standard form is set equal to 1. So I'm going to start with 9x squared plus 4y squared equals 36. And to get that equal to 1, I have to divide everything by 36. When I do that, this simplifies to 1/4. So x squared over 4 plus this becomes y squared over 9. And this is, of course, 1. That was my goal. So that's my equation in standard form. From that, I know that my y-axis is my major axis because there's my larger value for a. Because a squared is 9, then I know that a is the square root of 9, or 3. So let's start doing some things with the, well, I guess I could go ahead and do b. B is down here for, well, we'll go ahead and do b here. B is 2 because it's going to be the square root of 4. 3 is the distance from center to the vertices. B is the distance, 2 is the distance from center to the minor edge, the edge on the minor axis. So let's start doing some graphing. We know our center is at the origin because of the numerators over here. So center is here at the origin. I said that my major axis is my y-axis, so I'm going to go up and down from center to get to the vertices, and I'm going to go up and down 3. So this is going to be V1, and this is going to be V2. And it doesn't really matter which you name 1 or 2. You just pick. So my vertices are at 0, 3, and 0, negative 3. I also know from this that on my minor axis, on the x-axis, I go out 2. So those are going to be those edges of my ellipse on that side. I could go ahead and sketch the ellipse now if I wanted to. I could go ahead and draw that in. I still need to find my foci. Not a very good ellipse. Okay, so let's find those foci. To find the foci, I need to know C. And remember that we started with b squared equals a squared minus c squared. That was the equation we were given. So that means c squared is going to be equal to a squared minus b squared. So in this case, c is going to be 9 minus 4, that's square root. So c is square root 5, which means my foci are going to be square root 5 away. And my square root 5 is just over 2. So my foci, so it's going to be about 2.2. So my foci, my first foci is going to be right here, and my other foci is going to be right here. Describe how you determined which axis is the major axis. Well, the major axis has a squared, the larger number, in the denominator. Okay, I think that is everything. That is complete. Let's look at the next one. We're going to find the equation of this ellipse. So we're starting with some givens. We're given center at the origin, focus at 0, 2, vertex at 0, 5. So let's plot those. Center at the origin, focus at 0, 2, vertex at 0, 5. Alright, automatically we know that my major axis is the y-axis because it contains my vertices and my foci. And I can also place the other vertex in focus because they are equidistant from center in the opposite direction. So this is F1, F2 will be here. This is V1, V2 will be here, and again, the numberings doesn't matter. I could have done 2's up here and 1's down here. It wouldn't make any difference. So let's see what our calculations are. I know that A is the distance. A represents the distance from the center to the vertex, and A here is 5. C represents the distance from the center to the focus, and C here is 2. B we need to figure out. B is going to be that distance out to the minor edge. So I'm going to find that by using b squared equals a squared minus c squared, and that's that distance to the minor edge on the minor axis. So if A is 5, C is 2, then B is going to be the square root of 25 minus 4, or the square root of 21. Now to graph that, I need an approximation. So I'm going to plug that into my calculator and say, you know what, that is about 4.5-ish. So when I go out, I'm going to go out to about here for the edges on my minor axis of my ellipse. When I sketch my ellipse, I do my best to make it look elliptical. I have a hard time. Notice it's if I had done well, it would be almost a circle because my edges on my major axis go to 5, my edges on my minor axis go to 4.5. It's really close. It's much closer to a circle than this last one was, but it is not a circle. Okay, the last thing that we need to do here is give the equation. I'm not actually asked for that until the next page, but we're just going to go ahead and stick it here. So we know we have x squared over something plus y squared over something equals 1. That's my equation of my ellipse where the center is at the origin. The larger value, a, goes underneath the major axis, which is y. So this is going to be 25 because there's a squared. And then this one is going to be b squared. This is b is square root 21, so b squared is 21. Okay, what if we move our center away from the origin? If we move our center, remember we just did this on the last page. That's the end of that problem. It got split. If we move our center away from the origin, the center goes to HK, where H is my horizontal shift, K is my vertical shift. In the equation, it shows up just like we're used to seeing it. Nothing has changed as far as which my major axis is. Now, since it's moved away from the origin, the major axis is not the x-axis or the y-axis. It's going to be either parallel to the x-axis or parallel to the y-axis. That makes sense, right? So, for example, this ellipse is moved up and to the right. Its major axis is parallel to the x-axis because that's how it's oriented. This ellipse is moved right and up as well. Its major axis, though, is parallel to the y-axis. Okay, let's do one. Finding the equation of an ellipse whose center is not at the origin. So we are given some information where we can find the equation. Sorry, I had to stop for something to drink. Okay, plot the points on the graph, and then we're going to find the equation and do all of those things. So we have a center at -2, 4. My center is at -2, 4. So that gives me my numerators right there. So I can come over from my equation and say, okay, my center is x plus 2 gets me to -2. And y minus 4 gets me that up 4. And this is going to be equal to 1. I still have to figure out a and b. So I can do a square and b square. And a square will go, oh, we don't know that yet. Hold on. Focus is at 1, 4. So this is center. Focus is at 1, 4. So that is a focus. And then a vertex at -7. So it's going to be over here. -7 up 4. So that is, if this is F1, we're going to say this one is V2. Okay, so that tells me right there my major axis is parallel to the x-axis, because that's the direction that includes my center, my vertex, and my focus. So we're going to be parallel to the x-axis, which means the larger value, a square, is going to go underneath my x coordinate. Okay, so if I've got a focus over 1, 2, 3 units to the right, I will have a focus 1, 2, 3 units from the left, F2. And that distance from the center to the focus is C. So C is 3. If I have a vertex, this is at -2, this is at -7, so 5 units to the left. I also have one 5 units to the right. So I have another vertex here, and that means A is 5. And I need to find B. So B square is A square minus C square, which means B is 25 minus 9, which is the square root of 16, or 4. So I'm going to go from center down 4, and from center up 4. It's going to be 1, 2, 3, 4, right about there in my justify, right? Let's go ahead and sketch our ellipse. Vertex, vertex, minor axis edge, and come back around. Okay, that's not awful. So this distance is our, B. This distance is our C, and this distance is our A. When I come to finish my equation, my major axis is parallel to the x, so this is going to be 25, and then b squared is 16. There's my equation. And I started to say any questions about that, but you guys can't ask me questions in real time. I hate that. The next page, we kind of finished filling in some of this information we talked through here. A represents our distance from center to the vertex, and that was 5. C represents the distance from the center to the focus, and that was 3. And B is found using b squared equals a squared minus c squared, is the distance to that minor edge, and it was 4. We already did the equation on that last page, and we finished our graph on that last page. Okay, we are almost done. We've got 2 more examples to work through. We're going to graph another ellipse, and then we are going to use an application problem. So we've done all the hard stuff. I say that, and then we've got a little bit of arithmetic to work through here. So we are going to analyze the equation of an ellipse. We need to put that equation in standard form. Now, it didn't give us a lot of room to put that equation in standard form, so I'm going to use the back of my other page to put that in standard form. Okay, standard form means I have it set equal to 1, right? So I need my constant on one side. Let's just do this. Let's put our constant over here on the right, and then I'm going to group together my x's and then my y's. So on my left side, I'm going to have 25x squared plus 150x, and I did not leave myself enough room. Let me move down. 25x squared plus 150x, and then I'm going to have 4y squared plus 16y, and then I have that negative 91 on the other side. I want to complete the square for both of those, but those are such big numbers. I'm gonna make my life a little easier. I'm gonna factor out 25 here. Now we're still gonna have to deal with that, but if I factor out 25, that makes this just a little bit easier. And then here I'm gonna factor out 4, so that gives me y squared plus 4y, and then I'm gonna complete the square here. And then over here on the right, I'm going to have to add in the same amounts that I add in on the left, because that's how I keep my equation balanced on both sides. All right, half of b is 3, and 3 squared is 9. So I'm going to add a 9 here. Now I need to add the same amount to the right. I'm not just adding 9 though, I'm adding 9 times 25. 9 times 25 is 225. So that's what I need to add to the right, because that's what I have literally added in on the left. Okay, let's do this one. Half of 4 is 2. 2 squared is 4. But what I'm actually adding in here, because of this coefficient, is 16. So over here, I add 16. Now I factor. So I'm going to factor in here. I have 25 times, and then my factor here is x plus 3 quantity squared, because that half of 9. And then I have 4 times y plus 2 quantity squared, and that is equal to, over here I've got negative 91 plus 241. When I combine that, I get 150. Okay, I have completed the square. I need to set it equal to 1, and I'm going to set it equal to 1 by dividing by this 150, because that gives me 1 over here on the right. So I divide by 150 here, I divide by 150 here, and now having those coefficients out front helps me. 25 and 150, that gives me 6. So this first term is x plus 3 quantity squared over 6 plus, well, how many times does 4 go into 150? 4 does not go into 150 evenly, so we're going to end up, it's going to look a little awkward, but that's okay. We're going to have 150 divided by 4 is actually 37.5, with my numerator y plus 2 quantity squared. That's the equation of my ellipse. Alright, so I'm going to write it in standard form here so we can work with it. X plus 3 quantity squared over 6 plus y plus 2 quantity squared over 37.5 is equal to 1. There's my equation in standard form. Okay, from this equation I know that my major axis is my y-axis. The major axis is parallel to that y-axis. It's not actually on the y-axis, but it's parallel to the y-axis because that is my larger value, because a square is always larger, and a square is going to be 37.5 here. The center is given to me by these shifts that show up in the numerator. Remember, it starts as x minus h, y minus k. So my center is at -3, -2. My center is at -3, -2. I'm going to go ahead and sketch that. -3, -2, there is center. And I know that my y-axis is going to be the parallel for my major axis. So from center, my foci and my vertices are going to go up and down. If a squared is 37.5, then to find the vertices, I need to find a. So a is going to be the square root of 37.5, which comes out to be about 6.1. So from center, I'm going to go up 6.1, 1, 2, 3, 4, 5, 6, then just a little more, and down 6.1. So 1, 2, 3, 4, 5, 6, and just a little bit more. So that is going to be vertex 1, vertex 2. And those, the locations of those vertices are going to be at -3, and then we're going to say 4.1 for the one that's up here, and then we move down a little over 6, so that is going to be at -8.1. So that's the location, those are the locations for the vertices. Now what about the foci? The foci are c away, so that we've got to find c. Let's go ahead and do the major edges because we know, the minor edge, because we know that b is 6. Let's come down here and say b squared is 6, excuse me. So therefore b is square root 6, which is about 2.4, and that gives us the distance to the minor edges. So from C, I'm going to go 2, almost 2.5, so right back there, and 2 and almost a half, so right there. Those are going to be my minor edges of my ellipse. I can go ahead and sketch the ellipse at this point. It's a nice long skinny ellipse. We still need, however, to find our foci. So I need to know the distance of C. C squared equals a squared minus b squared. So a squared minus b squared gives me 31.5, which means C is going to be that square root, which when I plug that into my calculator is about 5.6. So from center I will go up 5.6 and down 5.6. My foci, that puts my foci at -3, about -7.6, and -3, 3.6. Those are the locations of the foci. So 3.6, F1, and -7.6 is going to be F2. Alright, I think that's it. I think we got everything in. Okay, application problem. Have you ever been to a museum or something with a whispering gallery where you can whisper at one side and they can hear it at the other, at a certain location on the other side of the room? Well, that works because of this conic section, this ellipse construction. A whispering gallery is constructed with a maximum ceiling height of 40 feet, and the distance between foci is 100 feet. We want to know how long the room is. Well, we've got a room, and we know the length of the room is going to be from V1 to V2. We've got a center, and the ceiling max is going to be at center. That's at 40 feet above center. And then we know the distance between the foci is 100 feet. So from F1 to F2 is 100 feet. Well, if this whole distance is 100 feet, that means this is 50 feet. But what we need is the distance from the center to the vertex. Well, okay, so what do we know? We know that B is 40 feet. And we know that this distance here, C, is 50 feet. What we need to know is A, right? So A square is equal to B squared plus C squared, because remember, for our right triangle that we have formed, this is A and this is also A. A squared, so A is going to be equal to the square root of 40 squared plus 50 squared. And if I plug that into my calculator, 40 squared plus 50 squared is 4,100. And the square root of that is 64. So the distance from center to a vertex is 64 feet, which means the length of the room is twice that. So my room would be 128 feet long. Make sure you don't forget to use units when we do the application problems.